Hello everyone, I am Olajide and welcome to another Capture the Flag security challenge on CTF security. Today, we're exploring the Deathnote CTF on TryAcme. This machine presents some exciting security challenges. First, we'll tackle the file upload vulnerabilities, focusing on manipulating file signatures, also known as magic numbers. Next, we'll uncover SSH key misconfigurations, explore Docker breakout scenario, and take a closer look at Linux file attribute like append only and immutability. So without further ado, let's jump right in. All right, welcome back to Deathnote CTF. And the very first thing we have here is the title of this CTF. We also have a tagline that says destroy the Death Note. And when you scroll down to the bottom of the page, we have two tasks. The very first one contains the description for the task, and the other contains the start machine button to fully deploy the machine. So I'm going to quickly do that, and this is going to take about 2 to 3 minutes for our machine to fully boot. And while we wait for that, let's take a look at what we have as our task description. So on the task one, we have your mission, should you choose to accept it, is to delete the Death Note located in the root directory. The Death Note is a supernatural notebook that grants its user the power to kill anyone whose name and face they know by writing their name in the notebook while picturing their face. The current owner of the Death Note is Light Yagami, a dangerous individual who is using the notebook power for his own purposes. He is accompanied by Shinigami, Death God Ryuk, who originally owned the notebook and is watching over the event with great interest. For your safety and to remove the power of the Death Note from their hands, you must find and delete the notebook. Good luck, Hackerman. The fate of many depend on your success in stopping Light Yagami and Ryuk. And as you can see, we already have our target IP. So I'm just going to grab that, and we're going to create our directory we're going to be working on this CTF. So let's quickly do that. So we're going to make directory, we're going to call it Death Note. And on the Death Note, we're going to create a text file, and let's quickly change directory to Death Note first. Then we're going to make, or we're going to use Sublime to create a text file called deathnote.txt. Okay, so I'm just going to replace my target IP here. Okay, so for my attacker machine, I'm just going to confirm I still have the same IP. So you can see the 10.2.19.105. So that is exactly what we have here. So I'm just going to close this, and let's head back to the TryAcme and copy out our target machine, and we're going to spawn this on the browser to see how the interface of this machine looks like. It looks like it's still booting in the background, so let's just give it few seconds. All right, great. Just make this bigger. All right, great. So you can see that we have a file upload functionality right here where we can upload file into this application. And when you click on the browse, it's kind of take you to your file manager for you to be able to specify the kind of file you want to upload to this application. And on the description here, we have upload a JPG image of the person you want to add to the death note, just like the description stated earlier. So I do have, looks like I do have a JPEG image. Okay, yeah, this happens to be one. All right, great. So this is a JPEG image, and let's go back to our application. I'm going to try to upload that particular image. I think I have it on the download. Cat.jpg, going to upload. So as you can see, we got no error and our file successfully uploaded. Now we're going to see how we can get malicious with this. So I'm going to try to upload a PHP reverse shell into this application and see if we can gain access through that particular reverse shell. So let's quickly get one from the Pentest Monkey website. So let's say reverse shell Pentest Monkey. Okay, this happens to be a cheat sheet. I'm kind of looking for a PHP reverse shell. Let's go back a bit, and all right, I found it. So I'm going to download this. Okay, so this is our PHP reverse shell, and I'm going to just extract the file. So where's the content? So we have our content in here, and we have our PHP reverse shell. So I'm going to copy this into the Deathnote directory. So let's paste it in here. Okay, so we can probably access it from here. Cat PHP. All right, great. So what we need to do is to modify the script IP address and the port number. So we can actually stick with the 1234 and just modify the IP address to our local IP address, which is the attacker's IP address. So what I'm going to do is use Sublime to open the PHP script. All right, nice. So let's quickly grab our attacker IP address, and we're just going to fix it in here. And I'm going to leave this port as 1234, and we're going to save this. Okay, let's try to upload the script on our application. So let's go to Al007, go to Deathnote. Let's switch this to all file and upload. Okay, so we get a warning. Oh no, I told you only files with the X signature FFD8FFE0. Are you trying to hack me? Okay, so let's grab this information. This is the only file signature allowed into this application. So just call this allowed file signature. All right. So let's see the first file we upload. Let's try to compare the file signature. I'll just open a new terminal and let's go to the download folder where we have our cat image. And we can actually, this is a cat image here. So we can actually use the xxd cat.jpg. Then we can just view the top part of the document, which is using the head command with just the first two lines. And you can see that this has the FFD8 FFE0, which is exactly why this particular cat image is being accepted by the application. On the other hand, if we check the file signature for the PHP reverse shell, XSD PHP reverse shell, and let's just view the top two. So you can see that we definitely have a very different file signature, which is the 3C3F70 file signature, which is the signature for this particular PHP script. So our main objective now is to be able to modify this particular PHP script to carry the same file signature that is being accepted by the application, which is the file signature for the JPEG file. Now, in order to do this, we need to first of all have our PHP script, which is exactly what we have already, which is called PHP reverse shell.php. So next, what we are going to do is we're going to create a file with the JPEG magic number, which is the exact magic number we are being given. Also know that this magic number are in X, so we can probably say, let's just clear the screen. So in order to create a JPEG magic number, we need to first of all create a JPEG binary file. So to do this, what we need to do is to use the echo command -ne, and this is going to make sure that we are interpreting the backslash in our output, and also we are not adding any new line in the output of our command. So the next thing we're going to do is to have the escape character, and then let's go ahead and pick our magic number, which is the magic number for the JPEG file. So I'm just going to paste this, and what we're going to do is to add the hexadecimal character here to indicate that this is an hexadecimal digit. So the next thing we'll do here is also add for the D8 and for the FF and also for the E0. So I'm going to close the quotation, and we're going to redirect this into a new file name, which we're going to call JPG magic number.bin to indicate that it's a binary file, and we're going to run this. So you can see that we've successfully created a new file. So let's actually see what we have. So I'm going to use the XSD JPG magic number.bin, and you can see that our file has the magic number for the JPEG file, which is exactly what we need. So the next thing we want to do is to concatenate this magic number with the PHP reverse shell magic number. So to do this, we're going to use the cat. First of all, we want the JPEG magic number to come first. So we're going to use the JPG magic number file. Then we want to concatenate it with the PHP script that we have, and then we want to call it exploit.php. Let's see what we have. So we have a new file created, and now let's check the magic number of our new file using the xsd command exploit.php. So I'm just going to extract only the first two lines. So you can see that we have our magic number prepended to the actual magic number for the PHP script. Now to move ahead, what we need to do is to check the permission of this file. And you can see that we have it to be read write only. So what I'm going to do is to change the permission. So let's change chmod, and let's just add execution permission to the exploit.php. So now we have our PHP script with the read write execute permission. So what we need to do is to upload this. But before we do that, we need to create a reverse shell on the same port, which is port 1234 on the reverse shell. So if you're lost, let's quickly view that again. So if I view the exploit, and when we scroll to the IP address and the port number, you can see that we have our attacker's IP address and port 1234. So I'm going to create a new terminal, call it NC, we're listening on port 1234. Okay, let's add the verbose. Let's clear this. So let's quickly upload our script. Deathnote, switch this to all. We're going to upload our exploits. Okay, great. So our exploit are successfully uploaded to the server. But now the problem is we do not know what particular directory we can trigger this PHP reverse shell we just uploaded from. So what we need to do is to find where all the uploaded data are being saved to. I could try to manipulate the file name here to upload. Of course, we have not found. I can also try just upload without the S. Still not fine. So what we need to do now is to perform a directory brute forcing attack, which we are going to use to find hidden directory from this web application. So to do that, we're going to be using the Go Buster. So let's quickly clear this. So first of all, I want to locate my word list. Let's say the Buster. There's this particular word list. I think it's this one. I just copy this. Okay, Go Buster word list. So to use the Go Buster, we're going to use the Go Buster, specify the directory, and our target is going to be HTTP, and let's get our target. Paste it right here. So we're also going to be having our word list, which is this one. No, not really. So I do not have Go Buster. I do not have Go Buster. So let's quickly install that. Okay, so let's have our command once more. So something else I want to add is the thread. Let's just use 50 thread, and let's do this in quiet mode. No such host. Oh, okay, that was a mistake. So we'll just wait for the Go Buster to navigate through the different directory within the web application to see if we can find the file upload directory where we can trigger our reverse shell from. Okay, so we found one, which is the /note. So I'm just going to copy and let's head to our machine. So I'm going to use /upload. Let's try to make this, okay, it's kind of big enough. So you can see some of the file I have uploaded so far, the cat image. You can actually open the cat image. You can see it here. We can go back. And this is the exploit code. So I'm just going to put this side by side with the terminal for our reverse shell, which is this one. All right, great. So what I'm going to do is to click on the exploit.php and we're expected to gain a reverse shell. So you can see I can type who am I and we gain a reverse shell as the dub data account. So what we can do is to stabilize this shell using the Python 3 and we can use the C and import pty dot spawn /bin /bash. Okay, great. We're going to export them equals to xtem. So we're going to put this in the background and then we're going to use stty raw echo. I'm going to put it back on the foreground. Okay, so let's see what we have. Let's put this on the background once more. Okay, great. So I'm going to clear. So who am I once more? Okay, great. We are data. So the next thing I want to do is to see the accounts that we have on this system. So I can easily go to the /home and run the ls. So we have two accounts on this system. We have the Light Yagami account and we have the Ryuk. And we can try to check if we have permission to view any of this directory. So we have absolutely no permission for this. You can see that Light is the owner of this directory and is also the group, and the group and others has no privilege on this directory. So I'm just going to leave this for now. For the Ryuk directory, as a group, you probably do not have the read and write permission. You can see it's totally empty, but we have read permission for others, meaning we can be able to view content of this Ryuk directory. So we can cd into Ryuk and we can ls to see if we have any file on this directory. Let's quickly check our machine to make sure that we have enough time. I'm just going to add 1 hour. All right, cool. So we have two files. We have the rotted creds and we have the user.txt. So let's see permission for these files. Okay, for the rotted credentials, Ryuk has read, write, and execute permission, and we are currently not logged in as Ryuk, so we have no privilege on this account. For the user.txt, we also have Light as the owner, and we have root as the group. So we do not have access. So when we try to cut roted creds, you see that we have permission denied. So what we can do is try to elevate our privilege. So first of all, let's try to view the user.txt. So we also do not have permission to view the user.txt. So what we need to do now is to look for a privilege escalation vector in order to gain access to either the Ryuk account or to gain access to the Light Yagami account. And to do this, we're going to use the LinPs privilege escalation tool. So let's quickly search for LinPs on GitHub. And this is expected to take us to the LinPs GitHub page. So I'm going to scroll all the way down and let's go to the release pages. So we have the limpis.sh. I'm going to download that and let's quickly go to our machine. Let's go to Deathnote. So we can stop this now since we have our upload directory. So I'm going to clear this and cd dot dot slash, just one step backward. So I'm going to cd downloads and we have our, we should be having our limpis here, which is limpis.sh. So I'm going to move this into, I'm going to move the limpis.sh into the slash home slash r007 slash Deathnote. So let's see the one step backward and see the Deathnote. All right, great. So you can see that we have the limpis.sh. So I want to change the permission to execute, or just for formality's sake. So we can probably change it on the machine. So the next thing I want to do is to set up a Python web server for us to be able to transfer this file to the target machine. So to do that, I'm going to use Python 3. I'm going to use the module and we're going to use the http.server, which is going to open the server on port 8000. So in order to receive this particular limpis.sh from our target machine, what we need to do is to use the wget http. So let's put in our attacker's IP address. So we need to make sure we indicate our port 8000 slash the name of the file we are getting, which is the limpis.sh, and this should be able to download the file. Okay, so we have an error. So let's quickly fix that. Let's quickly fix. I'm going to clear the screen. So wget http. I'm going to paste that one more time on port 8000 slash limpis.sh, and that should work. So you can see we probably have an issue here. So it says permission denied, cannot write to limpis.sh. So I think that is a problem because we do not have permission to write to the Ryuk account. So what we will do is to move to the temp directory, and I'm going to execute the same command. We should be able to write to the temp directory. All right, great. So we have our file transfer going on, and we have the limpis.sh saved. So let's quickly check that. And what I need to do is to use the change mod to add this to add the executable file permission. Then we're going to specify the name of the file. Great. So to execute, we just need to use the /limpis.sh. Wrong file name. limpis.sh. So what's going to happen is this particular application will try to look for different vector we can privilege escalate into root or other accounts within the system. So we have a lot of things coming up here. So let's just go to the top. So let's go to the top. Okay. Okay, yeah. So we have legend for this application. So if we have this particular color, which is a red/yellow, it indicates 95% of privilege escalation vector. We have the red, which means you should take a look to it. We have the light blue color, we have the blue, we have the green, we have the magenta color, and the like. So this is just basically the legend for whatever kind of privilege escalation vector the application is going to be presenting to us. So we have some exploits, which is the pawn kit. So I actually tried it out, but there's no reasonable result. So kindly indicate in the comment section if you are able to use the pawn kit exploit for this particular machine. So you can also try others like the pseudo baron same edit. We also have the pseudo baron same edit 2. We have the sub uid shell and the likes. So I'm just going to scroll down to something different. So we have cron jobs. Not really. Do we have cron jobs? No. Okay. Okay. Let's try to move. For the Ryuk account, some usable softwares, base 64. I'll call Perl, PHP, Python. Okay. What else do we have? Ooh, we have a private key. And you can see the location of this private key. So I'm just going to copy this and let's just add it. Found private key. Okay, so this private key, what I'm going to do is to copy it. So I do not know which of the accounts own this private key, but nevertheless, let's just try to set up the private key. Do we have any open terminal? This is for the VPN. Okay, so we no longer need this one, so I'm going to clear. So what I'm going to do right here is Sublime, and I'm going to call it ID RSA, and let's paste in our private key, and I'm going to save this. Also, what I need to do is to use since this is a private key, I'm going to modify the file permission to 600, which is going to be 600, that is 4 plus 2, which is read and write by the owner, and zero permission for the group and other users. I'm also going to specify the name of the file, which is the IDRSA. So let's see what we have. So we have our IDRSA. So what we're going to do is to try to use this to log in as one of the users. So I'm going to try it with the Lite account, since we have an account called Lite. In case if you're still wondering, so let's say cat/etsy/password. You can see that we have the Lite account and we have the Ryuk account. Ryuk has an ID of 1000. The Lite has 1001. So since the description says Lite Yagami is the one with the Deathnote notebook, so I'm just trying to log into Lite account using the SSH key we just found using the Linpiece privilege escalation tool. So let's head back, kind of mixing this up. Okay, so I'm going to use the SSH. We're going to specify the key, which is ID RSA, and let's specify the Lite account at. Then we're going to specify the target IP, which is the host, on port 22, which is the default port for SSH. So are you sure you want to connect? Yes, I want to connect. Okay. So unfortunately, we are being asked for password and we do not have any password for Lite Yagami account yet. So what I'm going to do is to exit. So let's just exit and clear the screen. So what we're going to do is to change this from the Lite account, and we're going to use the Ryuk and see if that works. Wow, great. And just like that, we are into the Ryuk account. So we can actually say, who am I? And you can see that we are Ryuk. And let's go to the list of files that we have, and we can probably cut rotted threads now. So we have this string. So what I'm going to do is to just copy this. It looks like a username and password. So what I'm going to do is to place this here, possible user name and password. So this is the possible username and password that we found. So what we're going to do is try to know what kind of encryption is being used on this particular password, because the password actually looks encrypted, but this is definitely not a base64 encryption. So what I'm going to use is try to use ROT13 in order to decrypt this particular data. So what we can do is try to use the tr command. The tr command is just a command in Linux that is used to translating or deleting characters from standard input and writing the results to a standard output. So we can actually use it to skip each of the character by rotating it to the 13th place and actually see what kind of output we get. Or we can possibly use CyberChef to CyberChef or any other decrypting tool in order to decrypt this particular encryption back to the original form. So to do that, first of all, we need to go to the terminal and we can say echo just by outputting the content that we have here. Then we can pipe the output into the tr command, and then we can specify our own regular expression. So the regular expression we're going to use is from the range of A to Z, which is capital letter. Not necessarily because we do not have capital letter here, but I'm just going to add it anyway. We need to also specify the lowercase from A to Z. Then we want to make sure that we are rotating to the 13th place. So we're going to have from A to N. So if you start counting, that's like 13 characters between. Then from N to Z, then to start back at A. Then we also have M, N. Then we have the lowercase to be Z A dash M. So I hope that's correct. I'm just going to try to run that. So you can see that we've successfully decoded this particular password string into the original form, which is the light, and this is the password. So I'm just going to copy and then let's go back to our notes and decrypted using route 13. All right, so now that we have password, we can actually log in as light to see if we'll be able to access the user.txt file. So while we are doing that, let's see at user.txt. Do we have access? No, we do not have access. So who is the owner of the file? We have the owner of the file to be light. So now that we have light account, I can actually switch user to light. And for the password, we just got the password for the light account. So I'm going to paste this in here. So we're currently logged in. So let's just go one step backward. CD lights. Okay, nothing here. So still going back to the Ryuk account. And just like that, we found the user.txt flag. So I'm going to just grab this and let's head to try hack me. And we are going to paste our first flag. Okay, that was correct. Now for the root flag, we need to gain access to the root account. So let's go back. So let's go back to light account, and remember we still have our temp file, which is the okay, it's no longer here. Okay, can I switch back to it? Okay, cd temp, cd/temp. Oh, I lost the link piece. Do I still have the output? No, I do not have the output. Let's go. I think I have the one for data, data. Access to dub. Yeah, okay, that's it. So let's try to see if we have another vector to gain access to root. Do we have another vector? Let's see /password. Okay, this is the private key. Okay. mount. Okay, so in order to not waste time, let's go back to um, let's go back to the Ryuk account. Okay, so let's cut etc/password once more. And okay, this still the light account, so let's switch to light. For the password, still same password. Okay, so let's say groups. So you can see from the output that the current user light belongs to two groups, the light group and the Docker group. Now you might be wondering what Docker is. Docker is a technology that lets us package application and their dependency into standardized unit called containers, making it easier to deploy and run application reliably across different computing environments. In order to check if there is Docker present on this particular machine, what we need to do is to run the PS, and to view the process, what we need to do is to pipe this into queue, just in a quiet mode, and we're going to search for Docker, and then we want to be able to execute echo Docker is running, or if it's not present, we want to be able to execute echo Docker is not running, just to verify that we have Docker on the machine. So we have Docker, sorry about that. Let me just make this bigger. So we have a command that says Docker is not running. Okay, I think I missed something here. I missed a grep. Okay, yeah, correct. So we have Docker is running on the machine. So the next thing we want to do is to be able to understand what kind of privilege escalation vector we could perform on this machine. Now, if the light account belongs to the Docker group, what this actually means is that the light account has the privilege to execute Docker commands without needing to use sudo. This simplifies the Docker operation for the user but increases the risk if the user's account is compromised or misused. And we're going to be looking at how we can use this particular Docker group in order to escalate our privilege into the root user account. So to do this, what we need to do is to set up a Docker container that we can potentially use as a means to manipulate the host system from within the Docker container. And we're going to be seeing how this works in just a minute. So the first thing we want to do is to check for Docker images. So I'm going to use the Docker images command. And this is going to list the Docker, and we can see that we have a Docker repository called Alpine, and we have the tag to be latest, and we have the image ID, we have the date it was created, and we have the size for the Docker container. Now the next thing we need to do is to spawn up this Docker container. To do that, we're going to use the Docker run, and we're going to make sure it is interactive session and we're going to mount this volume of the root directory into /mnt, meaning we will be able to access the root directory of the host machine from the /mount directory on the Docker container. So the next thing we need to specify is the name of the Docker container, which is the Alpine. And then we need to specify the tag, which is latest. Hope I spelled that correctly. And then I'm going to run. Okay, so who am I? So you can see that we are currently root on this machine. So I can do ls. So we can see what we have here. We have a different directory within the container. So these are all the directory within the container. We have the bin, the dev, the etc, home, and the likes. So remember, we mounted the root directory of the host machine to the mount directory. So we should be able to access the host machine from the mount directory. So let's quickly see the into mnt. And when we do ls, we're going to see another copy of the root directory, which is the original copy for the root directory of the host machine. So remember, we have our flag in the root directory. So I'm going to cd root. So when we do ls, you're going to see that we have the root.txt. So I can cut root.txt, and we have our flag. But we have a note here saying, here is your flag, but please remove the Deathnote before leaving Hackerman. So we have our Deathnote here, but remember, we are still inside the container accessing the root directory. So what I can do is to try to break out of this. And in order to do that, I'm going to copy our flag first, and we're going to paste it in here, and we're going to submit. Now what's left is actually logging legitimately into the host machine and deleting the Deathnote. So for us to do that, we're going to head back into our machine. So remember, we can actually, since we have the root access on this host machine, we can actually modify the sc/shadow to carry the same password with the light account, so we can be able to log in as root account. So to do that, let's use the vi. Let's check, do we have vi? Which vi? Okay, yeah, we have vi. So I'm going to use vi to edit the /sc/shadow file. Not really what we want, so I think I messed something up there. So I'm going to just exit this. So let's use the escape. This is Vim, so we're going to use the queue, I guess. Okay, great. So for us to be able to modify that, let's view what we have again. So I'm going to go one step backward. So we want to access the etc. So we should be having vi etc/shadow file. All right, great. So now, since we have the password for the light account, I'm just going to copy the hash, the password hash for the light account, so that we can log in as root with the same password that we have, which is the light account password. So I'm going to copy this, and then we're going to switch to insert mode by hitting the I key on the keyboard, and then we should be able to navigate to be able to insert text into this particular shadow file. So let's see if that's working. Yeah, so it's working. So I'm going to delete the actual root password, and we are going to replace this with light password. So in order to save I hit the escape, then the column WQ. So just to verify, etc/shadow. So we should be having the same password as light and root, which is actually correct. So now what we can do is we can exit this Docker, then we can switch to root with the same password for light. Since we've modified the hash, we should be able to have access. So you can see we're currently logging as root. So who am I? We are root account. So let's move away from the temp directory to root. So cd root. So what we need to do now is to delete the Deathnote. So I can quickly say remove rf Deathnote. So we have something and it says cannot remove Deathnote, operation not permitted. Now, most of the time, the reason we have this kind of error is if we have the file attribute. Now, most of the time, the reason why we have this kind of error is if we have the immutability file attribute set up on a file. Now, we can verify if that is the case here by using the lsattr, which is going to list the attribute of the file. So we can specify the name of the file, which is Deathnote, and you can see that we have the immutability and we have the append only for this particular file. Now what's going to happen is this attribute that we have for this file is going to prevent us from deleting this file. We can only append to the file, and in order to remove or to strip off this immutability and append file attribute, we can use the chattr tool, which is the change attribute, and we want to strip off the immutability and we want to also strip off the append only, and then we can then specify, let's just do this one after the other, and then we can specify the name of the file, which is Deathnote. Okay, so you can see we have a note. It says Sparrow was too smart, and then we have the command we actually supply to the change attribute command. So in this case, one thing I can do is to switch my shell. So we can actually switch our shell to another kind of shell. So we can now run this command. Copy. Okay, so let's check if we still have our attribute. We're going to use the initial command we used. Sorry about that. Which is the list attribute. So you can see that the file immutability and the append only has been stripped off from the file. So you might be curious what is actually happening here. If we go to the let's say ls, what do we have? Okay, we have lspals, which is going to view all the file, and we have a file called .bashrc. If we cut .bashrc, okay, so we have some alias and stuffs like that, and you can see that the alias for the chatr has been set to echo Sparrow was too smart, and that was why we're having that issue when we're using the bash shell. So switching the shell actually fix the issue. So to solve the problem, if we want to use the change attribute without encountering any problem, we can just remove this. So what I can do is to um, actually use the vi, same vi, to modify the .bash rc, and we can scroll all the way down. So we can edit this just by adding a comment to remove this line, and I can actually save this. Let's exit this shell. So now when we run the change attributes, it looks like we still have the same thing. Vi bash dot bash rc. We still have it. Do we still have it? Do we still have it? Okay, so let's just escape. So let's cut dot bash rc, and let's grab I'm going to ignore case arc sparrow. Okay, this has been commented, so why on earth are we still having something similar? So let's say change attribute. Okay, let's modify that. Okay, so let's scroll all the way down and ensure we have the alias line commented out. All right, great. So we have the alias change attribute still commented out. So I'm going to exit. So here, what we can do is to reload the bash rc file so that the changes we made can take effect. So we can use the source, and I can specify slash dot bash rc. Okay, so let's check the change attributes command if we still have. So we still have it as sparrow is too smart. So another thing we can do is to use the on alias command to remove the chat attribute. Okay, so let's check if that works. Chat. Okay, great. So we can see that we've actually removed the sparrow is too smart string from the terminal. So now we can actually remove the file attribute, immutability, and the append only attribute. So to do that, we can just use the change attribute. We can use the tag I for to strip off the immutability, tag A to strip off the append only. Then we'll specify the name of the file, which is the Deathnote file. So now I can use the rm rf remove Deathnote. So you can see that we've successfully removed the Deathnote, and we're left with the root.txt. So we can cut that one more, and you can see here. Okay guys, that will be all for now. Thank you for watching. If you find this video helpful, please like, share, and subscribe for more content on cybersecurity and ethical hacking related topics. See you in the next video.